Throughout the upcoming lectures, you will gain a comprehensive understanding of the various parameters associated with the ChatGPT API. This knowledge will empower you to utilize these parameters with confidence in your own projects. If you go to the OpenAI playground, these parameters can be found on the right-hand side panel. In this lecture, we will focus on the temperature parameter and then move to other parameters in upcoming sessions. The temperature parameter in the ChatGPT completion API controls the randomness of the model's output. It affects the level of exploration or creativity in the generated responses. To illustrate this, let's submit the following prompts with different values of the temperature parameter, starting with the value of 1, then a value of 2, which is the maximum allowed value, then going down to values near 0. So I'm going to start with a temperature of 1, which is the default value, and submit the prompt multiple times. One more time, and one more time. So if we analyze the responses, we can see that with a temperature of 1, the output is relatively diverse and random. Each submission generates different completions while maintaining a general sense of what doctors represent. Now let's try with a temperature of 2, which is the maximum allowed value. So a temperature of 2 increases the randomness and diversity of responses further compared to a temperature of 1. But bear in mind that there is a great risk here of generating responses that don't make sense. So the language model becomes very creative, but sometimes it will go to the extent of generating responses that don't make sense at all. So in this example here, we call doctors are academic advocates, not just dispensers of commercial prototypes, which doesn't make too much sense. Now let's try with a temperature of 0.3. So that's the first response. Second one. And then third one. So with a lower temperature of 0.3, we produce more focused and deterministic responses. So you can notice here that all the responses here speak about the role of doctors and their relationship with patients. So here it says expected to treat their patients, provide medical care, and here they diagnose and treat medical conditions. So the completions this time are relatively consistent, and they exhibit less randomness across multiple submissions. Now let's try a temperature of 0, which is the minimum value allowed. So first response, and next one, and next one. So we can see that with a temperature of 0, the responses become deterministic, meaning they are identical for each submission. The model here selects the most probable completion based on its training data, resulting in consistent outputs regardless of the repeated prompts. To conclude, we can say that a higher temperature increases randomness, resulting in more diverse and creative responses. A lower temperature makes the model focus on tokens with higher probabilities. Now let's understand how the temperature parameter works behind the scenes and how it affects the randomness of ChatGPT's output. When you submit a prompt to ChatGPT, the model will do some sampling to determine which tokens will go next. Based on your prompt, there are tokens which are more likely to come next and others which are less likely. ChatGPT will calculate for each of those tokens a value. This is what we call the Logits. The Logits values are then converted to a sampling probability for each token. In this example, to make things simple, just imagine that we have only 5 tokens instead of millions of tokens in reality. Each of these tokens has a probability of appearing next. Tokens with higher probability have more chances of going next. Now the question is, what happens when you change the temperature? When we talk about applying a temperature to the logits, it means modifying the logits values by introducing a scaling factor, which is the temperature parameter. The temperature parameter controls the level of uncertainty or randomness in the predicted probabilities by changing the values of the logits. So by applying the temperature to the logits, we adjust the sensitivity of the model's output. So a higher temperature value greater than 1 will result in more softened and diverse probabilities, spreading the probability mass across different classes. This means that the model becomes more uncertain and assigns more comparable probabilities to different classes. So in this example here, we've got new values for the logits, and that led to new probabilities of sampling for each of our 5 tokens. And you can see that the probabilities this time are comparable, as you can see in this graph. So a higher temperature makes the probability distribution flatter, giving lower probability tokens or less likely tokens a higher chance of being sampled. So the different tokens have comparable probabilities of being sampled in the output, and that is the secret behind the increased randomness in this scenario, as all tokens have comparable chances of being sampled. However, as you've seen in the examples, a higher temperature also increases the likelihood of generating incorrect or nonsensical answers. Conversely, a lower temperature value will sharpen the probabilities, making them more focused and distinct. The model becomes more confident and tends to assign higher probabilities to the most probable classes or tokens, while suppressing the probabilities of other classes. As you can see in the probability graph, the different tokens do not have comparable probabilities of being sampled in the output, as the more likely tokens are a lot more likely to be sampled than the other ones, as reflected in their significantly higher probability of sampling. And that is the secret behind the decreased randomness in this scenario, as all less likely tokens are given very low chances of being sampled, unlike the more likely ones. Bear in mind that lower temperatures produce more precise and sensible answers, but may lack variation or creativity. When you go with a temperature of 1, which is the default value, this is more or less what the probability distribution will look like. So the temperature parameter is useful in situations where we want to explore the model's uncertainty or control the level of confidence in the predictions. It can affect the diversity and stability of the model's output probabilities, allowing us to fine-tune the behavior of the model based on specific requirements or use cases. The temperature parameter, again, is set to 1 by default, but as a developer, you can adjust the temperature parameter to balance randomness and consistency based on your desired application or user experience. In the next video, you will understand the max tokens parameter. In this video, you will be introduced to the max tokens parameter of the ChatGPT API. The max tokens parameter allows you to control the length of the response generated by the model. By specifying the maximum number of tokens in the response, you can customize the length to suit your specific needs. When making an API call, the model generates a response by predicting a sequence of tokens based on the provided prompt. However, without specifying the max tokens parameter, the response can potentially be very long, leading to increased processing time and higher costs. By setting the max tokens value, you can limit the length of the response to a desired number of tokens. Let's run this prompt to illustrate this concept. In this scenario, the max tokens parameter is set to 256 tokens. And you can see that in the code, inside the objects that we pass to the createCompletion method. Max tokens set to 256. Setting the max tokens parameter can be particularly useful when you have constraints on the response length, such as character limits in a chat interface, or the message size restrictions in an application, or just cost considerations for the token usage, which is really important. Speaking about cost, you would need to remember that both the prompt and the response count towards the total number of tokens processed by the API. So you're going to be billed for both. So in our scenario, we've got 54 tokens, and that's the total of the input and the output, or the prompt and the response. So the max tokens parameter will only control the output of the model, not the input, which is something that you control yourself. So you would need to optimize the prompt itself and then control the output using the max tokens parameter. It's also important to note that setting a specific value for max token doesn't guarantee that the response will precisely match that token count. So if I reduce the maximum length here to 20, for example, and run the prompt again, we have been cut off here because of the max tokens value that we set. So the model will attempt to generate a coherent and meaningful response, but may adjust the response length slightly based on contextual factors and available tokens. So when choosing the max tokens value, you need to strike a balance between the desired response length and ensuring that the response remains contextually appropriate and meaningful. So if you set the value too low, like in this scenario, this will result in a cutoff sometimes, or an incomplete response. While setting a really too high max tokens value may lead to unnecessarily lengthy replies, which will increase your tokens usage. In the next video, you will understand the stop sequences in the ChatGPT API. In this video, you will dive into the usage of the N parameter in the ChatGPT API. The N parameter, short for number of completions, plays a crucial role in shaping the behavior and output of our completion model. The N parameter allows us to specify the number of alternative completions we want to receive from the model for a given prompt. So by adjusting this parameter, we can explore different possibilities and gain a deeper understanding of how the model generates responses. When you set a higher value for n, such as 5 or 10, you instruct the API to generate multiple completions for a single prompt. This can be particularly useful when we want to explore diverse responses or gather different perspectives on a given input. It allows us to uncover a range of possible answers or generate creative variations. Conversely, if we set n to 1, we limit the API to providing a single completion. This can be beneficial when consistency or deterministic responses are preferred, ensuring that the model consistently generates a specific answer for a given prompt. If you check the OpenAI playground, you will not find the N parameter in the right-hand side panel. So we're going to have to include it directly into our code. This is the code that we created in the first chapter of the course, which we use to send requests to the OpenAI API. So I'm inside the server.js file in the backend, And I'm looking now at the run completion function, which we use to send requests to the API. This is the object where we place all the parameters that we send to the API. And one of those parameters is going to be n. But before adding n, let's run a prompt using the current code and see what we get. So for example, the color of the sky is, and here we've got our prompt, we've got the response text, and if we check the data objects, we can see that inside the choices value, we've got an array, and inside the array, we've got only one object, and that's our response. So this is where we're getting that text. We're just getting it from the first element inside the choices array, and we're getting the text value from that element. So what I'm going to do now, I'm going to add the n parameter, and I'm going to set it to 3. So let's save. Let's run the prompt again. And this time, if you check the choices value or array, you can see that our array this time has got 3 objects. That's the first one, which we printed right there, because we only print the first one, if you remember how we wrote the JavaScript code in the first chapter. And then that's the second choice, and that's the third choice. Now, bear in mind that when you set the max tokens of 10, that is the maximum number of tokens that can be used for each of these choices. So if you look at the total tokens here, or the completion tokens, we used 24 tokens in the output, which is the sum of the tokens used by each of these choices. All right. So it's important to note that while increasing n can provide more diverse outputs, it also increases the cost and sometimes the response time of the API requests if n is too high. Therefore, it's crucial to strike a balance based on the specific requirements of your application. Alright, in the next video, you will understand the echo parameter of the ChatGPT completion API. In this video, we will explore the echo parameter of the ChatGPT API. The echo parameter plays a crucial role in controlling how the ChatGPT model responds to user inputs. When making API requests, we can include the echo parameter to specify whether we want the model's response to include or exclude the user's message as part of the generated output. So by setting the echo parameter to true, the model will incorporate the user's input in its response. This can be useful in scenarios where we want to create a more conversational flow, providing a context-aware response that acknowledges the user's query or statement. Also, this simplifies the process of combining the prompts and completion for easier output handling. Bear in mind that the cost is not affected by echoing the prompt. Charges are based on the completion tokens. The echo parameter is one of those parameters that you won't find in the right-hand side panel of the OpenAI playground. So you're going to have to incorporate it directly into our code. So we're going to remove the and parameter for now. Before adding the echo parameter, let's just run a query without it. So complete the sentence Einstein is. So this is our result, and as you can see, it doesn't include the prompt. Now let's use the echo parameter and set it to true. So by default it's set to false. Now let's set it to true, And let's run our query again, or our prompt. And this time you can see that ChatGPT included or echoed our prompt in the response. Again, this does not affect the cost, as you'll be charged only for the number of completion tokens. Again, if you set the echo parameter to false, the model will generate a response without including the user's message. This can be beneficial when we want to obtain a more concise and focused answer from the model without echoing the user's input. Alright, in the next video, you will get introduced to the top P parameter of the ChatGPT API. In this video, you will understand the top P parameter in the ChatGPT API. The top P parameter in ChatGPT is used to control the diversity of the model's responses by limiting the probability distribution to the most likely tokens. It is also known as Nucleus Sampling or probability threshold sampling. The value of top P ranges between 0 and 1. The default value is 1, but you can select any value between 0 and 1. So here's how it works. The model generates a list of probability values for each token in the response. So just imagine that we've got only 5 tokens. So each of these tokens has got a probability value that is calculated by the model. The tokens are then sorted in descending order based on their probabilities, starting from the most likely tokens. The cumulative probability is calculated by summing up the probabilities. Tokens with a cumulative probability exceeding the specified top P value are considered for sampling. So in this example, we've got a top P value set to 1, which means 100%. So we're going to consider all the tokens in this scenario. Now let's move to the next scenario where top P is set to 0.78 or 78%. As you can see, only the first 2 tokens are considered for sampling this time, and that's because their cumulative probability is greater than 78%. If we move to the next scenario where top P is set to 0.52 or 52%, only the first token is considered this time for sampling, and that's because its probability is greater than 52% or equal to 52%. So by adjusting the top P value, you can control the diversity of the generated responses. A higher top P value, for example 0.9, allows more diverse and varied responses, including tokens with lower probabilities. A lower top P value, for example 0.2, makes the model more focused and conservative, generating responses primarily from high probability tokens. Now, if you set the top P value to 0, it means that no tokens will be considered for sampling. In other words, the model will only generate responses from the most likely token according to the probability distribution. Now let's try this in the playground. So I'm going to start with a top P value of 1, which means 100%, and run the prompt multiple times. So that's the first response. That's the second one, and that's the third one. So as you can see, a higher top P allows more diverse responses, including the tokens with lower probabilities. Now let's reduce P to 0.2, for example. And run the prompts. So as you can see, the model this time is more focused and conservative. If you compare this answer with the third one, they are actually the same. Now, if you go even lower and set top P to 0 and run the prompt again, you will expect more or less the same answer. Now, before concluding, it's very important to understand the difference between the temperature parameter and the top P parameter. The temperature parameter will change the way the probabilities of these tokens are calculated. So it's going to eliminate the less likely tokens by reducing their probability. So they have less chances of being sampled in the output. While top P will eliminate the less likely tokens using the cumulative probability that is provided, which is the top P value. And that's the difference between those two parameters. So using the top P parameter will help you strike a balance between exploration and exploitation in the model's output, which will allow you to fine-tune the level of randomness and creativity in the responses. In the next video, you will understand the frequency penalty in the ChatGPT API. In this video, you will understand the frequency penalty and the presence penalty of the ChatGPT API. Let's start with the frequency penalty. According to the documentation, if you set this parameter to a positive value between 0 and 2, you will then penalize new tokens based on how many times they have appeared so far in the prompt response. And as a result, you will decrease the model's likelihood to repeat the same line verbatim. So what does it mean? It means that if you set this parameter to 1, for example, or 2, then new tokens will get a penalty based on how many times they have appeared so far in the prompt response. So if a certain token has appeared so far 5 times in the prompt response, later on that specific token is going to be less likely to appear again, because we will apply a penalty to that token which is proportionate to the number of times that token has appeared so far. And you will see this in detail when we cover the examples. Now, moving on to the presence penalty, it's slightly different. If you set this parameter to a positive value, then you will penalize tokens based on whether they appear in the text so far. So if a certain token appears at the beginning of the prompt response, then regardless of how many times it's appeared so far, you will apply a fixed penalty to that token, and that penalty is calculated based on the value of the presence penalty. As a result, you will increase the model's likelihood to talk about new topics. So these two parameters are slightly different. The frequency penalty is proportionate to the number of times the tokens have appeared so far in the prompt response, while the presence penalty is a penalty that is applied automatically to any token that has appeared even once in the prompt response so far, and it doesn't change if the token appears multiple times or one time only. All right. Now let's use some illustrations to understand this further. Suppose that you set the frequency penalty to 2, the maximum number allowed. Now, let's suppose that we've got only 5 tokens for simplicity, and this is the most probable token, which has got a probability of 52% of being sampled. Now, if this token has appeared 0 times so far in the prompt response, then the applied penalty is going to be 0%. So that means that we will decrease that probability by 0%, which means it's going to stay unchanged. Now, if that token appeared so far one time in the prompt response, then, for example, the applied penalty is going to be 20%, which means that its probability of being sampled is going to be reduced by 20% compared to the original value. So we went from 52% probability to 41.6%. Now, if that specific token has appeared so far twice in the prompt response, then later on in the response, its probability of being sampled is going to be reduced even more. And here the applied penalty is 40%, which is twice the previous penalty of 20%. So this is just a good example to show you that the frequency penalty is proportionate to the number of times that token has appeared so far in the prompt response. Now, if that token appears 5 times now, we can say that the applied penalty is going to be 100%, which means that its probability of being sampled now is actually 0%. So that token is going to stop appearing further in the prompt response. Now, moving on to the presence penalty. Again, we will suppose that we've got only 5 tokens, and we set the presence penalty to 2, the maximum number allowed. If our token has appeared so far 0 times, then the applied penalty is 0%, which means that its probability of being sampled is unchanged. Now, if that token appeared 1 time so far in the prompt response, then the applied penalty, for example, is going to be 20%, which means that we will reduce its probability of being sampled by 20%, reducing the value of the probability to 41.6%. Now, if that token appeared 10 times so far in the prompt response, the applied penalty is unchanged, and it's going to stay at 20%. And that's because the presence penalty is not proportionate to the number of times the token has appeared so far in the prompt response, unlike the frequency penalty. Now, to understand these two parameters further, we're going to run the following prompts with different values of the frequency penalty, and then run it with different values of the presence penalty. Now, just bear in mind that the frequency penalty and the presence penalty can have values between -2 and 2. So setting a positive value will apply a penalty, while setting a negative value will encourage repetition. So let's go ahead and run our prompts using different values. Let's run our prompts with different values of the frequency penalty, starting with 0, then 0.5, then 1, then 2, and also trying negative numbers to encourage repetition. I'm going to pause the video to save you time and run the prompts with the different values. Then I'm going to come back when I get all the outputs ready for analysis. Now let's analyze the results. For clarity, I added the frequency value at the top of each response. So if we set the frequency value or the frequency penalty to 0, we get a normal output of 50 numbers as requested. Tokens are not penalized based on how many times they appear so far in the prompt response. If we set the frequency penalty to 0.5, the penalty consequences start to appear for the most frequent token, which is the comma. Its probability of being sampled is reduced to 0 from this point after appearing 36 times. So we can't see it anymore. Also, we got only 49 numbers instead of 50. That's because from this point, all numbers between 1 and 6 now have been penalized enough to make their probability of being sampled nil. Let's check what happened with a frequency penalty of 1. The comma stopped this time appearing after showing up in the output 20 times instead of 36 times in the previous scenario. And that is a good reflection of what happens when the penalty is doubled from 0.5 to 1. We got 49 numbers again, with a frequency penalty of 2. The comma appeared only 12 times before being eliminated. Each of the numbers between 1 and 6 appeared only 5 times before being eliminated, meaning their probability of being sampled further is now reduced to 0. And we have an output of 34 numbers only, instead of 50 numbers. What is amazing here is that 0 started appearing, unlike in the previous frequency penalty values. But if you look closely, 0 started appearing after all numbers between 1 and 6 appeared once. This means that they got penalized enough after appearing once due to the high frequency penalty value. Now, if you look even closer, you will see that after 0 appeared the first time, it got penalized as well enough, just like the numbers 1 to 6. So they all appeared again before their sampling probability dropped again below zeros, and 0 appeared again. And we carry on like that. So after generating 34 numbers, the model can't generate any further tokens, as all the possible ones now have a probability of sampling reduced to 0% due to the high penalty. Now, if you set the penalty to a negative value, for example -2, you will encourage repetition, but the output can be of poor quality. The effect here is the opposite of what happens when you penalize the tokens. The comma, which is frequent at the beginning of the prompt response, is now the favorite later on in the prompt. Instead of being penalized, its sampling probability is now higher, resulting in its repetition. Now I'm going to pause the video, then run the prompt with different values of the presence penalty parameter, then come back to you when I get the results ready. Applying the presence penalty to this prompt does not have a great impact on the response, as we have a limited number of possible tokens, but it is worth comparing the outputs with the ones we received when setting the frequency penalty, especially the comma. So when setting the presence penalty to a positive value, the comma does not get penalized for its frequency here, as it gets penalized only once. So it does not stop appearing at some point in the prompt response. And you will see that in all positive values. Now, when the presence penalty is set to a negative value, any number that comes first will be prioritized for repetition straight away. In this example, the numbers 1 and 4 appeared first, so we had some repetitions of those numbers, well, only number 4, and then number 6 appeared later on, so we had repetitions of 6, 4, 1, and then later on number 5 came, and then we kept repeating the numbers that appeared so far, and then number 2 appeared, and then we kept repeating all those numbers for quite a long time until number 3 appeared later on. And after that, all the numbers had more or less the same probability of being sampled. So before a certain number appears, it has to wait, as its probability of being sampled is lower than those of the numbers that have already appeared. And that's because of the negative value of the presence penalty. But once that number appears in the response, it starts appearing just like the others. Hopefully this gave you a good overview of the frequency and presence penalties in the ChatGPT API. I'd recommend using a higher frequency penalty when you want to reduce the repetition of certain words or phrases in the generated responses, and applying a higher presence penalty when you want to encourage the model to talk about new topics. It's important to note that the optimal values for these parameters may vary depending on the specific use case. So experimentation and fine-tuning are recommended to find the right balance for your particular application. In the next video, you will understand the stream parameter of the ChatGPT API.